Okay, so we're going to do a quick demo on RIP. Before that, can I ask you a few questions on RIP?
Yes, sir.
Okay, what is the maximum hop count RIP supports?
16, 0 to 15.
Correct. Now, what prevents loop in RIP?
Well, I think is a number of, no, the split horizon.
Exactly. Split
Split
horizon
horizon, yes.
prevents loop. What if, you see, split horizon is enabled on all interface, and when I say show interface G3/0, you can see that. Let's show IP interface. You can see the split horizon is enabled. What if I
Right.
disable it? What if I disable it? Then which one will guarantee me the loop avoidance? How can loop be prevented if I say no IP split horizon when I cancel? Now you see I have removed split horizon, and you can see split horizon is disabled. Now, what will guarantee me a loopless?
Let me see.
No problem. Take your time. You see.
Was it the poison reverse?
You are close. You see.
Road poisoning?
These things are close to the answer. You see, I have disabled split horizon in this point, in this port. All right? I've disabled.
Yep.
Now, this network, which was advertised in this path, and this network, which was advertised like this, they are learned by the adjacent router. So R3 learns about this network 10, 2, 2 via this port. And because split horizon is enabled there, 10, 2, 2, 0 won't be given this way.
Right.
But when I disable split horizon, this will go. When this goes, what will R2 do? R2 will say, hey, your RIP, your administered distance is what? 120. But I already have directly connected. For directly connected, what is the administrative distance? 0.
1.
No,
0,
0.
0.
0. So I'm not going to take what you're giving because I have the same network directly connected. You understand?
Yes.
So there's not going to be a loop now. There's not going to be a loop. But when this directly connected goes down, when this goes down, router 3, every 30 seconds when it sends the update comes to router 2 on the same port where this network was earlier advertised. Same port is coming. Now what R2 will do? There is no 0. Administrator is 0 now. It's gone. It was earlier connected directly. Now it is gone.
Right.
When 10 to 0 comes now, R2 will learn it. R2 will learn 10 to network. What will be the metric? 2. How? Earlier, when R2 was advertising, what was the metric?
So,
One hop.
over here it was with
One hop.
Okay.
It was telling router 3, hey, I got 10 to 2. For you, it is one hop. Now, R3 is saying, for me, it is one hop. If you will take my advertisement, then it is two hop for you.
Okay.
R2 learns it. And R2 learns thinking that R3 has got this network. Is this correct? No, it's not correct. Now R2 gets its turn. R2 gets its turn. Every 30-second update should be sent. It gets its turn. R2 says, if anyone is taking my update, it is 3 for him. Because locally what?
Right.
Locally, it is 2.
It's 2.
Now what R3 will do? Oh, earlier R2 only gave me one hop. Now he is giving me 3 hop. So let me learn. It's not one hop anymore, it is 3 hop. And now router 3 gets its turn. For me it is 3 hop. Whoever receives it, for you it is 4 hop.
Wow.
Now this guy learns. Likewise, the route will be advertised. Now, someone is pinging that network. 10, 2, 2, 2. The packet comes to R2. R2 says, I know who is having this. R3 has this. So R2 forwards the packet to R3. What R3 will do, I know who is having this. R2 is having, it goes to R2. And then R2 again sends to R3. Again, see, the packet that was coming is looping.
Right.
Now, when will this stop, When this update from 3 it will go to 4. And from 4 it will go to 5. And this will learn as 5 and now it will advertise as 6. And then this guy learns as 6. And this guy says, for me it is 6, for you it is 7. And it keeps incrementing when it reaches 15. This guy learns and he will say, for you it is 16 hop. This is what you are answering. It will say, for you it is 16 hop. Then immediately it will say, route poisoned, possibly down. When this says possibly down, R3 will say, hey, you were the one who gave me the route. You are saying possibly down, let me also make it as possibly down. That's called poison and reverse. You see, what you said is correct, but it takes some time. It takes some time because the periodic update is only every 30 seconds. So every 30 seconds, the hop count is going to increment on both the router. And when it reaches 16, which means 16 times 30 seconds. Yeah. So almost 1 minute. Almost 1 minute it will take for deciding that it is possibly down.
Right.
No, it's not 1 minute. It's more than 1 minute.
Yeah. Because 16 times,
yeah,
isn't almost 1 hour.
1 hour.
Yeah.
1 hour or 12 minutes.
There's somebody about.
Okay, so for 16 times 30, 6 3s are 18, 8, 1, 3, 3, 4, 480 seconds. 480 seconds, which is how many minutes? Yeah, almost divided by 60. 636. Yeah, 7, 8, almost 10 minutes, okay? It's almost 10 minutes. So for 10 minutes, all the packet that was coming here will be also looping. Oh, that will bring down your network, I tell you.
Yes, because almost 10 minutes
It's too much.
looping. Right.
All right, so do not disable split horizon. Do not disable split horizon. Split horizon is the right answer. Split horizon prevents loop. Only when you disable split horizon, the loop prevention mechanism is going to be the infinite metric 16 hop, which is route poison and poison reverse, both. But that is going to take a lot of time, almost 10 minutes. Okay, so let us put the split horizon thing back. Okay, I configured split horizon again, and I'm going to verify split horizon is enabled now. So don't touch the split horizon, which is enabled by default. Do not touch.
Right.
Next, I'm going to remove the RIP protocol, which is already running. Let us verify. Show IP protocol. You see, I already have RIP version 2 running here. And I'm going to remove this. I think this is the lab which we did in the previous class, correct?
Right. Yes, yes.
Okay. To remove a routing protocol, simple command is this. No IP routing. This command will remove all the routing protocols that you have enabled. I have actually only RIP. What if I have RIP, OSPF, blah blah blah, many more things? It will remove all of them and put back this command IP routing. See, you don't need to remove no router RIP. You don't need to remove one protocol after the other. You simply type that no IP routing, and now you check the show IP protocol. There is no protocol.
Right.
So the best command to remove all the routing protocol is say no IP routing, which means you are disabling the routing feature, and then you enable routing feature. When you disable routing feature, all the routing protocol should get disabled. Easy way.
Right.
Now, what are the other ways to remove the protocol? You know it. If I want to remove
Yes, you
RIP,
can remove them one by one.
no router RIP. This is also another way. Show IP protocol. Now you see RIP is gone. Now let's move on to route 3. New IP routing. IP routing. Okay. I'm more comfortable with this command because if I have BGP, OSPF, I will not be knowing the autonomous system number, etc.
Right.
So to know that, I need to type few commands. Instead of that, to remove this easily, I can put no IP routing. It removes all routing protocol whatsoever, the autonomous system number or the process ID. We have enabled RIP on all these three. I'm going to enable it one more time to show you a few things like route poisoning. I already showed you offset lists, I remember. I
Yes.
would like to show you offset list. Sorry, I would like to show you split horizon now. And the authentication part. Router,
Right,
right?
but you just said the authentication is just as
Same as
EIGRP.
EIGRP, correct. Okay,
Right. So
then let us keep it for now. Let's
Yes.
quickly verify that split horizon thing. Sorry, not split horizon thing. Poison reverse. Have we seen poison reverse in the previous lab?
No, I
Okay,
haven't.
that's what I want to show you. Router rip, and then I'm going to say the networks that I would like to run on this are 10 and 170. No, version 2. No other summary. Now, RIP also supports equal cost load balancing. Every routing protocol except BGP supports equal cost load balancing. What is equal cost load balancing? If you have multiple paths with same number of hops to reach the destination, it can use more than one path in the routing table. Yeah. In the routing table, it can have more than one route if the hop count is same for a destination. Now, how many routes maximum? Can you say how many routes maximum for a
How many route
destination?
maximum? No, I'm not quite sure.
For a destination, you see, show IP route. For a destination, say for example 10.1.1.1 network, if I learn 10.1.1.1 network via multiple paths, up to 4 paths you can see in the routing table. Show IP protocol. You see max path 4. I think you asked this question in the
Yes.
previous class as well.
Yes, I did. I did. I did.
But if you want to decrease or increase, you can do so by putting this max path command router rip maximum path. You see, maximum path. I can make it as 2 also if I don't want 4. You see now, it is turned to 2.
Right.
Yeah. So now you know how to change this. You know how to change this as well. Yeah. Okay. Now, can we change these timers? Sorry. Have you tried changing any of these timers? 30 second.
I haven't. No, I haven't. But I know they're supposed to be able to change. You can change them
Yeah.
to provide maybe a fast reroute or something like that.
Router rip. Guess which time will be the which command we should use. Do you see the command to change the timers? Periodic
Timer,
update.
timer, timer. Yeah. Down at the bottom, I said timers.
Okay, good. So you have seen this. Good. Timers. So these are the things that you should try in your lab. Basic.
Okay.
And now this is the periodic update timer. What is the default?
30.
Yeah. And if I want to make it as 10, I just put 10 here.
Okay.
And then invalid, the default invalid is?
Default invalid 16.
No.
Oh, no, invalid. Oh, 180.
180 seconds. Now I can say,
180.
no, I don't want 180 second. Make it fast like EIGRP. Then I can say 15 seconds. Yeah. EIGRP is
Right.
only 15 seconds to decide someone is dead. Invalid. Now hold time. I can say 20 seconds. You can hold it in the routing table for 20 seconds, and then it will do route poisoning after 20 seconds. By default, hold time is also 180
Okay.
seconds. Yeah. By default, route poisoning is also 180 seconds. I'm saying no. Do it in 20 seconds. Don't wait for 180 seconds. And then flashing out. Flash out in 25th second. Now you see, in less than 25 seconds, the convergence will happen. So you are making the RIP protocol fast like other protocols.
Right.
But why people are not doing this? Because it's going to be process consuming one. Why? Because RIP is not sending incremental update. RIP is going to send the complete update every 15, every 10 seconds. Here you say 10, no? Every 10 seconds it is going to send the entire routing table. So the bandwidth consumption is going to be very high. It's not like EIGRP. EIGRP sends only hello packets, isn't it?
Yes.
Hello packet is very tiny. That you can send very fast, very often, no problem. But periodic update sending 10 second, it's not that good, no? So people are not doing this because of the CPU and bandwidth consumption.
Okay.
But I just want to show you that there is an option in case if you want to speed up. I do not want RIP to be slow. I want to speed up. I don't care about the bandwidth or the CPU. Then you can do this. Let's go and verify. Show IP protocol. You see, the timers, everything got changed.
Yep.
Now what I'm going to do is, I'm going to paste this on every router.
So let me ask a question.
Yes, please.
If it's different, if it is different for each router, does it make a difference?
Of course it will make a difference. Because this router is going to decide some network is dead in 15 seconds. This router is going to make it as invalid in 15 seconds. But if this sends update every 30 seconds, R2 is sending every 30 seconds. But R3 already decide you are dead.
Oh, okay.
That's not good.
Yes, 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 yes.
R2 has thrown the root from the routing table in less than 25 seconds before the update comes.
Before the update comes.
So every time it throws and then learns, not good. The packet will get lost. Many traversing packets will find root, and then after some time there won't be root. Again it will find root. So there will be pinging and stopping, and pinging and stopping, and pinging and stopping.
Right.
So that's not good. You have to put it on every router if you do this. So I'm going to put it on every router. I'll go to router 2 now. Router RIP version 2, and I paste it. And then the networks are 172.16, 10, no auto summary. Let's move on to router 1. Router RIP.
That's router 1.
Yeah, router 3 is done. Sorry, it's router 1.
Oh, router 3 is done. Okay, okay. Okay, okay, okay.
Router RIP version 2. Auto summary. And then the metric, timers, and then the network. And then done. Okay. Now we have made RIP to be more fast in convergence. So when I test it now, it should be very fast, not slow like before. To decide possibly down, it should not take much time. Let us see. First of all, I want to check the route. Show IP route RIP. Look at this. I'm learning 10.3.3 and see the timer here, 5 seconds. See only the timer, 7 seconds, 9 seconds, again 0 0. After 9 it becomes 0 0. What does it mean?
Mean that you get updates?
It got updated on the 10th second
Right.
because we have configured show IP protocol. We have configured to send update every 10 seconds.
10 seconds.
Now let's verify one more time. 7, 8, 9, 10. Okay, first. Every 10 seconds the update is coming. Now I'm going to this one, not 1033. I'm going to shut down that port there. On router 3, it is loopback 0 interface that has got 10333. Am I right?
Yes,
Interface
that's
loopback
right.
0. I'm going to shut down. And now I'll show you here. Now you see, it's gone. It's gone very fast.
Oh, very fast, yes.
Right. So because we,
In no time.
we changed the timer and it should have taken at least 20 seconds, but in the real world, it'll take the timer. It won't be this fast. In the real
Right.
world, it will definitely take maximum of 25 seconds to read. Maximum.
Right.
Yeah, mostly in 15 seconds it'll say possibly down, and then
Possibly
in
down.
another 5 seconds it will remove. It won't hold. After 5 seconds,
Right.
it will try to flash. So this is how you can make RIP also to be one of the no, not one of the RIP also to be faster.
Faster.
Okay, now these are the
But
things.
it will be
It will be what?
too CPU intensive because
Correct.
it will be sending too much updates. And if it's a big row, if the routing table is big, then it'll be just no use.
Very correct. If your network is big, your routing table is going to be big, and the bandwidth consumption, CPU consumption, everything is going to go high. Not good.
It's back.
Not good.
It's back.
Yep. Because I say no shutdown. All right. So this is what I thought. Is left, which we have not covered in the lab in the previous class. So
Right.
I completed it.